Hello everyone. This is going to be the homework take-up for the lesson on the intersection of a line and a plane. There are quite a few questions here, so just kind of bear with us and we'll work through them all. Okay, so this is question 5a. Okay, basically, do these two things intersect? Okay, so I'm going to guess the issue here is because the equation is in vector form. Okay, and I did kind of make a side note, I think, during the lesson, if you watched the video, that in order to do this intersection process, okay, it's best to have this in the scalar form, right? So I'm going to want to convert this equation to the scalar form. Okay, so my first step there is to find the normal to the plane. So my normal, and that is the cross product of the two direction vectors. So I have 1, -3, 1, and I'm going to cross that with 2, 3, and 1. Okay, so we'll just run that through quickly on the side. Kind of wishing I had a calculator button that would do that for me. But let's see. We've got -3 take away 3, so that's -6. We've got 2 take away 1, that's 1. And we've got 3 plus 6, so that's going to be 9. Okay. Now that I have that, I'm going to create the scalar form of my equation. So I'm going to just jump ahead here. It's 6x plus 1y plus 9z, and it should be a -6, plus some constant d is equal to 0. Okay, I plug in my point, so 4, -15, and -8. Okay, and I think when you bring that around, this is the second take of this video, so I think I got d was like plus 111 the last time I did this. Okay, so that means my equation is going to be -6x plus y plus 9z plus 111 is equal to 0. Okay. So now I have to see if my line intersects with this one. So I'm going to use the parametric form of this line and plug it into this equation here. Okay, and again, I'm going to jump a little bit. So my parameters are for x, my parameter would be 5 plus k. For y, my parameter is -9 minus 12k. And for z, my parameter is 3 plus 2k plus 111 is equal to 0. Okay, so let's see what happens. -30 minus 6k minus 9 minus 12k plus 27 plus 18k plus 111 is equal to 0. Okay, first looking at my k terms, I have -6, -12, and plus 18. So that gives me 0k. And looking at my constants, I got -30 minus 9 is -39 plus 27 is -12 plus 111 is 99. So 0k plus 99 is equal to 0. So this says that 99 equals 0, and that doesn't make any sense. Okay, so therefore, they do not intersect. Okay, there is no solution, so they don't intersect. All right, next one. Okay, 6c, determine the distance between the parallel line and the plane. Okay, so our line was 0, -1, 1, plus k 6, 4, -7. Okay, and here's the equation of the plane here. Now, you might be looking at this saying, hold on a second, is that really a plane? Because I just have x and y. Okay, yes, even though z is missing, okay, it's still the equation of the plane they gave us, so we'll have to use it the way it's here. Okay. They want distance, so let's review how to do distance. Okay, if that's my line, and they've told us it's parallel, so we're gonna have to assume they're good there. Okay, the idea is that I know what my normal is already. Okay, my normal would be coefficient of x, 2, -3. Okay, there is no z term, so my third coordinate is going to be 0, and that's my normal. Okay, I do know a point on the line, so let's call that A. And that point is 0, -1, and 1. So I'm going to find some other point on the plane. We'll call that x. Okay, and then we'll project that onto the normal, and that will give us our distance. So looking at my plane here, a nice easy point to use would be x is 1. Okay, so I'd have a 2 there, if y is 0. And then z is not in the equation, so it really shouldn't matter what I use for z. And that seems weird. Okay, again, I'll keep it simple just in case something comes up. But yeah, it really isn't going to matter. And sorry, that's a point. I should be using round brackets. So 1, 0, and 1 is on the plane. Okay, that's my plane x. So my vector from A to x is going to be, let's see, 1 take away 0 is 1, and then 1. Okay, 1, 1, 0. Okay. And now, I have those two things, right? To find the distance, I do the magnitude of the projection of AX onto N. Okay, so that's the magnitude of the dot product or the magnitude of N. Okay, so it's the magnitude of 1, 1, 0, dotted with 2, -3, 0. Okay, all over square root of 2 squared plus -3 squared plus 0 squared. Okay, so in my denominator, I've got 4 plus 9, so it's root 13. In the numerator, I've got 1 times 2, so I've got -1. Magnitude -1 over root 13, so 1 over square root of 13. Okay, which is about 0.28. Okay, and just again, to note quickly there, here, right, in the normal, the value of the z-coordinate was 0. So it wouldn't have mattered what was sitting here in A to x. It would have gone to 0 anyway, okay? So which is why I didn't really apply there, okay? But yeah, that's kind of a weird thing, is that it was missing that coordinate. But there you go. The distance is about 0.28. Okay, 7c, determine the distance between these two planes. Okay, so we definitely didn't cover this directly, but we do have the tools we need to figure this out. Okay, so first thing to note here, because I'm talking about distance between the two planes, that kind of implies they're going to be parallel. Right? I should have one plane sitting above another one. Okay, and I'm just going to briefly talk about why that is before we solve this. So if I look at my first plane, right, the normal of that first plane is going to be 2, -3, and 1. My second plane is 4, -6, and 2. Okay, these two vectors are scalar multiples of each other, right? The second one is the first one times 2. So that means on my original plane, right, if this is the normal vector in the equation for the first one, then this right? Just something bigger, same direction. So that implies that the two planes have to be parallel. Okay. So that's good. That means I already know what my common normal is. So the rest of the procedure is going to be the same as what we did for a line and a plane, or a point and a plane. Okay, I'm basically just going to figure out a point on the first plane, a point on the second plane, x, find my vector ax, and then project it onto the normal. Okay, so same kind of procedure here. We're just going to need to take a minute to figure out some points. So for the first one, actually, we'll kind of make it simple here. I'm going to go for the z-intercepts of both planes. So for plane one here, which I'm going to do and keep doing in green here, if I put in a 0 for x and a 0 for y, I would have z is equal to 6, so that means z equals 6. Okay, so I'm going to call that my point A. Okay, and on the second plane for point x, I'm going to do that again. So I have 0, 0. And now I have 2z equals 8, so z is equal to 4. Okay, so this is going to be a very simple vector ax. My vector from a to x would be 0, 0, -2. Okay, and now let's work through our projection. Projection n over ax. And I want the magnitude of that, so I just need to do the magnitude of ax dot n, or the magnitude of n. Okay, so this will be a nice easy dot product. 0, 0, -2 dotted with, I'm going to use the smaller one just to keep my numbers nice. So 2, 3, 2, 3, and 1. And that's all over the square root of 2 squared plus -3 squared plus 1 squared. Okay, so magnitude of -2 over square root of 14. So that's 2 over root 14. And the decimal equivalent of that is about 0.53. Okay, so yeah, the procedure was similar to one we done earlier, just it was a little different with the two planes. But yeah, point to point and project it onto the normal. Okay, 8a, determine the distance between each point in the plane. Okay, again, I think we did do something like this before. So there's my plane. Okay, the point is up here. So that means I do know what my normal is. So I'm going to find some point on the plane and then project that over here. Okay. So my normal vector from my equation is 3, 9, and -1. Okay, again, to go easy on myself here, for the point on the plane, let's do something like my z-intercept. So 0, 0, I have z, -z minus 1 is equal to 0. So if I solve that, I think I'm going to get z is equal to -1, right? Okay, so for my vector from a to x, this is my x, this is my a, so 0 minus 2, -2, -1, and -7. Okay, so projection of ax onto n, and that's magnitude is equal to magnitude of the dot product. Okay, so we've done this lots, so let's try to speed this up a tiny bit here. Okay, ax dotted with n. So -2 times 3 is -6, minus 9, which is -15, plus 7, so that should be -8, over the magnitude of 81 plus 9 is 90, plus 1 is 91. Okay, so it should be 8 over the square root of 91. So that must be a little bit less than 1. About 0.84. Okay, on to the next one. Okay, number 9. Write an equation of a plane that contains these 2 points P and Q and is parallel to this line here. Okay, this question is definitely not directly linked to the lesson from the previous day, but we did do this a few lessons back. Okay, so again, let's try to draw this out. Okay, I have some plane, I have point P and point Q, okay, and I have a parallel line up here with a point and a direction vector. Okay, so what do I need to create the equation of a plane? Okay, I need either the normal and a point, okay, that would be for the scalar form, okay, or I need 2 direction vectors and a point to the vector form. Okay, so because I have points P and Q, I can get a direction vector on the plane, and I have points, okay, and my second direction vector will be whatever this vector's direction is up there. Okay, so we're going to start with the vector form because of the type of information we were given. So I have x, y, z is equal to, we'll pick one of the points, I'll say point P to -3, 6, plus, I'll start with the vector I want to given. I've got t, 1 to -3. Okay, and then for my other direction vector, we need to get it going between these 2 points. So from P to Q, that is 4 take away 2 is 2, 1 take away -3 is 2, and -2 take away 6 is -8. So to make that easier, because this is the direction, I'll call that 1, 1, and -4. Okay, so make myself a bit of room here. This is plus S, 1, 1, -4. Okay, and I just checked with the back of the book, and I realized I made a silly little algebra mistake here. So let's back this up a tiny bit. Okay, 4 minus 2 is 2. 1 minus -3, that's +4. Okay, 2, 4, 8. And again, I'll make this simpler, okay, by dividing it all by 2. So I'd say 1, 2, -4 would be slightly nicer to work with. So 1, 2, -4. Okay, the back of the book does list the 2, 4, 8 there as well. Okay, and again, just to quickly review, if I wanted to get this to scalar form, right, I would need to take the cross product of my 2 direction vectors, right, start filling in my ABC and my scalar form around. Okay, but there's the equation of the plane. Okay, number 10. Does the line through these 2 points intersect this plane? Okay. Well, let's start by getting the equation of the line. So I'm going to have my vector AB, which is equal to 4 minus 2 is 2. 0 minus 3 is -3, and 2 minus 2 is 0. Okay. So does this intersect with this plane? Okay, wait, sorry, this is direction vector. Let's finish the line. The line is xyz equals q. Right, that was my first point. Plus, we'll say t times 2, -3, 0. Okay, so see if they intersect. We'll get my parametric form and plug it into my equation. So I have 2 times my x parameter is 2 plus 2t. My y parameter is 3 minus 3t minus 3. My z parameter is 2 plus 0t, so just 2 plus 4 equals 0. Okay, 4 plus 4t plus 3 minus 3t minus 3, oops, 6 plus 4 is equal to 0. Okay, so I've got t and 4 plus 3 plus 4 is 11, minus 6 is 5. Okay, t plus 5 equals 0. I get a value for t. So to answer the question, it does intersect. Because I did get a value for t, and that's all I need to do. Okay. As a little side note, okay, I remember when I first looked at this question and started putting it into the slides here, if you look at point B and actually plug it into this equation, I'm pretty sure it actually works. You have 2 times 4 plus 0 minus 3 times 2. Oh, wait, maybe it doesn't. I thought it did. Nope, never mind. It doesn't work. Okay. I guess I did not eyeball that correctly, but that could be another quick check. See if I'm trying to trick you, right? Just throw in the points to the equation and see if either of them goes into the equation. Okay, but yeah, we created the equation of a line, right, in the vector form, right here, and just plugged in our parameters of the equation and solved. Okay, last one, number 17, and there's a bit of stuff going on here. Okay, so they gave us 2 lines, and they conveniently put a K in one of the coordinates here. So first, 17a asks us to create an equation of a plane that contains line 1 and is parallel to line 2. Okay, so for part A, first, okay, in the vector form, okay, it contains this line, so that means I've got that point and my first direction vector. All right, and then it's parallel to the other line, so it must contain that vector as well. So those are my 2 directions. Okay. Okay, part B says the value of k such that line 2 lies in the plane. Okay, well, again, that's kind of talking about intersection. So to make my life easier, I'm going to need to change this over to the scalar form before I start working on B. All right, so let's go through those steps. All right, I got to figure out my normal, which is the cross product of those 2 vectors. Okay, 1, 1, -3, 1, 1, -3, 2, 3, 1, 2, 3, 1. So 1 plus 9 is 10. -6 take away 1 is -7. 3 take away 2 is 1. Okay, so I've got 10x. So my point was here. So 10 times 1 minus 7 times -2 plus 4 times 1 plus d is equal to 0. So I know that was 28. So d equals negative 28. The scary thing is, as I'm writing this down, I've taken this question up probably every single time I've taught this course, and I could see that 28 coming when I started running this through. Okay, so there's the scalar equation. Okay, I'm just going to copy this line so I can see what I'm working with. Okay, so for part B, okay, I want to figure out the value of k such that that line lies within the plane. And the talking about a type of intersection. So I'm going to put my parameters into my scalar equation. So we have 10 times 4 plus 2t minus 2 times, let's see here. No, sorry, back up. I'm getting myself mixed up. Okay, minus 7 times, and then my y parameter is negative 2 plus 3t. And then plus 4. Z parameter is k plus t. And minus 28 is equal to 0. Okay. So, I've got 40 plus 80t minus 14 minus 21t plus 4k plus 4t minus 28 equals 0. Oh, wait, it's not 80. What am I doing? That's 40 plus 20t. Okay, so I can see there's going to be a little bit of an issue here. So just bear with me for a second. There's something I must need to correct if this question is going to work out. Okay, I found a mistake, and it's just a silly thing. I swapped those values. That was plus 1 times 4, which means this is actually a 1. Which means down here, this is actually a 1. So, okay. That's better. And, yeah. No, I was worried because my t's need to cancel out for this to work, right? I have 20 minus 21 plus 1, right? I have to have that 0t if it's going to lie in the plane. Okay, and then for my other terms, okay, I've got, what do we got here? I've got 40 minus 14 minus 28. So I believe that is negative, not sure, negative 12 maybe? Okay, negative 2. Okay, I get negative 2 from all those constants, and I still have a plus k kicking around. Okay, so the t's are gone. I rearrange it, and k should be equal to 2. Okay, and again, check with the back of the book. It's not 2. Okay, and again, because I'm making some silly algebra mistakes here. I think this negative 7, that should be a plus 14. So that's 54, and then minus 28 which would be 26. Okay, so k is negative 26. All right. You can tell this has been a long video. All right, last one. It's kind of the same question. Determine the value of k such that those things are 10 units apart. Okay, so I'm going to need to bring down these two things again so we can see what we're doing here. All right, so I want value of k such they're 10 units apart. So again, we'll quickly review the procedure. I have a plane, I have a line above it. Okay, I know what the normal to the plane is, so I'm going to find a point on my line and a point on the plane, find the vector running from a to x, and project it onto the normal. Okay, difference being here, right, my plane, I have a general point there. Okay, so if this is my point A, okay, I need a point X on the plane. Okay, to make the numbers simpler, I know that 7 goes into 28. So if I make X 0 and Z 0, okay, then Y should be equal to negative 4, I believe. Yeah, we get positive 28, take away 28 is 0. Okay. So my vector running from A to X is going to be negative 4. Negative 4 take away negative 2 is 2. It's negative 2. And 0 take away k is negative k. So to make that a little nicer, let's get rid of those negatives. That would be similar to doing 4, 2, and k. Okay, and I know what my normal vector is. My normal was 10, negative 7, and 1. So how do I use the distance? The distance is the projection of AX onto the normal, and it's the magnitude of that. So magnitude of AX dot N over square root of, all right, back up, root magnitude of N. All right, so my AX was 4, 2, and K. 4, 2, K, dotted with 10, negative 7, 1. All over square root of 10 squared plus negative 7 squared plus 1 squared. Now, I already know what my target is. That's supposed to be equal to 10. So, 10 equals magnitude of 40 minus 14 plus k over square root of 150. So 10 times square root of 150 is equal to magnitude of 26 plus k. All right. So this came up on the last assignment. Okay, this branches into two possible solutions, right? It says the magnitude of this is equal to 10 root 150. So that means that either, okay, this started as positive 10 root 50 or 10 root 150 equals 26 plus k, Or it could mean that this became negative 10 root 150, and then the absolute value stripped that away. So negative 10 over root 150 is equal to 26 plus k. Okay, and I just bring the 26's over. So either this is 10 root 150 minus 26, or this is negative 10 root 150 minus 26 equals k. I was just checking with the solution manual. It's online. They made a little mistake in their solution. I'll just show you briefly here. Down here when they were doing the dot product, they had 10 times negative 3 is negative 30. Negative 7 times 0 is 0. But then 1 times 4 minus k suddenly became negative 4k, which is not correct, right? They should have had plus 4 minus k, which would give you a variation of what we had here with 26 plus k. Okay, so these are the two answers, and if you want to run that through your calculator, you can see what the values are. Just one last little thing there. If you're wondering why we get two values of k, like what's the deal with that? Remember, it had to be 10 units away. So one possibility is that my line is above the plane, and it's 10 units above that. Okay, the other possibility is that it's below the plane, and it's 10 units below that. And those are my two options. Okay, that was a lot of homework, but again, thanks for sending in those questions. I'm sure lots of people have the same questions as you when you sent those in. All right, thanks for watching, and the next lesson will be posted on Monday.